This is Mr. Martin. These are video notes for Precalculus Honors. This is section 3.3. We're going to be talking about properties of logarithms. So let's start with the change of base formula, which you may have seen in Algebra 2. So if I have the log base a of x, I can split this up into whatever base I want. So I could have log base b of x and then log base b of a. So notice how I split up the x and the a, and then I give it whatever base I want. So typically what we're going to do with this is we're going to use the change of base formula to change it to either a base of 10, so we'll change it to a base of 10, or we'll change it to a base of e, because we have these buttons on our calculator. Alright, so we like these. Typically use change of base to change to base 10 or e. Alright, and again, that's because on our calculator we have, over here you can see we have this log, that's log base 10, and here's our natural log, that's a log base e. So let's go ahead and try this out for a few. So evaluate the following using your calculator. 1, use common logs, and 2, use natural logs. So for part 1 here, this would be the log base 10, and again, typically if it's 10 we don't write it, of 16 over the log base 10 of 3. So let's come over here, and we've got log 16 divided by log 3, and that's going to give us 2.52. Alright, and then let's try this with a natural log. So I have natural log 16. So again, we're just changing it to a log of base e, and natural log 3, and we should get the same answer. So natural log 16 divided by natural log 3, and we get 2.52 as well. Alright, so go ahead and if you want to pause the video and calculate for B, C, and D, or whichever of those you want, and then when you restart the video, I'll have the answers up there for you so you can check to make sure you did it right, just to get a little practice. So pick 1 or 2 or all 3 if you like, and then when you restart, the answers will be there. Alright, so here's the answers for parts B, C, and D, so you can double check those. If you're having trouble with your calculator, make sure you check in with me. Moving on, more properties of logarithms. We have product property, quotient property, and power property. And again, these should be familiar to you from Algebra 2, but if they're not, they're relatively straightforward. So for the product property, if I have the log base a of u times v, we can separate the product here into the sum of 2 separate logs. And this goes forwards and backwards. So we can take a product and separate it into a sum, and we can take a sum and put it back into a single logarithm of a product. Alright, and so here's with the log base a. Again, it'll work with the natural logarithm. It'll really work with any base. Alright, and then the quotient property. So we have u divided by v. This would separate into log base a of u minus log base a of v. Again, similar with natural logarithms. Then we have our power property. So the log base a of u to the n, we can take this exponent here and we can move it out to the front. Okay, this can go either way as well. So this would become n times log base a of u. And sometimes we'll want to take that coefficient and put it back as an exponent. Again, these work both ways. Alright, so let's look at a few examples here. So for number 2, we want to write this in terms of natural log of 2 and natural log of 5. So natural log of 10 is going to be the same as the natural log of 2 times 5, which we can separate to the natural log of 2 plus the natural log of 5. For part B, this is division here, and again we want to write it in terms of natural logs of 2 and 5. So this is going to be the natural log of 5 minus the natural log of 32, and we know that 32 is going to be 2 to the 5th. So then this would be natural log of 5 minus natural log of 2 to the 5th. We can take this and move it out as a coefficient. So we would end up, our final answer here would be natural log 5 minus 5 natural log 2. Alright, moving on to part C. I know that 20 is going to be 4 times 5, which is going to be 2 squared times 5. And 125 is 5 cubed. So this is going to be the natural log of 20 is 2 squared times 5 minus the natural log of 5 cubed. And the natural log of 2 squared, so that's going to be 2 natural log 2 plus natural log 5. So this whole first term here, this whole first term becomes this. And for the second term, we're going to have minus 3 natural log 5. Alright, again, if you have questions, make sure you get those answered. Alright, next example, expand the following logarithmic expressions. So now we're going to go the other way. So we have log of 3x squared y, so we have a product here. So it's going to be log 3 plus log x squared plus log y. So we'll take this exponent and move it to the front. So we have log 3 plus 2 log x plus log y. This will be our final answer for this, expanding it completely. For part B, let's recall that a square root, we can also write that as an exponent of 1/2. So this is going to be the natural log of 4x plus 1 to the 1/2 minus the natural log of 8. We'll take the exponent, move it out to the front. So it's going to be 1/2 natural log 4x plus 1 minus natural log 8. Now be careful here because this is not a product. It's not a natural log of a product, so we just leave it in this form here. Alright, moving on to the last one. We have the log of x times x plus 2 over x plus 3 squared. So let's separate that division into subtraction. So I have the log of x times x plus 2 minus the log of x plus 3 squared. So I have a product of x and x plus 2, so we'll separate those. So that's going to be the log of x plus log of x plus 2. And then we'll move that 2 over to the front, the exponent to a coefficient, minus 2 log x minus, plus 3. Alright, and that would be our final answer there. So again, problems 2 and 3 are kind of going opposite ways. Actually, we're expanding for both of these, and then for example 4, we're going to condense it. Alright, so let's take a look at number 4. Write the following expression as a single logarithm. so let's start with these coefficients and bring them back into exponents. So I'm going to have log of x to the 1/3. Make sure it doesn't look like a base there. Plus log of x minus 3 to the 5th. And then this sum, we can bring these together. So it's going to be log x to the 1/3 times x minus 3 to the 5th. And typically we don't like to keep it as fractional exponents, so I'm going to do one more step and make this the log of the cube root of x times x minus 3 to the 5th. We'll put that all in parentheses. Alright, and anytime you want to just pause the video and work these out on your own and then just check when you're done, feel free to do that. I'm going to go ahead and work out these other 3 examples for you. So let's start by bringing this coefficient back into an exponent and the 2 back to an exponent. So I'm going to have natural log x minus 4 to the 4th minus natural log of x squared. This difference is going to become a quotient. So we'll have natural log of x minus 4 to the 4th over x. Alright, moving on. X squared. There we go. Alright, so I'm going to take this 1/5 and I'm going to distribute it. So, and once I distribute it, it's going to become an exponent. So the first term is going to be log base 3 of x to the 1/5 plus log base 3 of x minus 2 to the 1/5. Now I have a sum, so I'm going to combine that to a product. So I have log base 3 of x to the 1/5 times x minus 2 to the 1/5. And one more step. We'll combine this to the log base 3 of x times x minus 2 to the 1/5, which becomes log base 3 of the 5th root of x times x minus 2. Again, we typically in simplest form don't have fractional exponents, so we'll change that back into a root. And then this would be our final answer. And the last example here, let's combine, or let's move this exponent first up to there. So I have log of x squared plus 3x plus 2 minus log of x plus 1 squared, and then we can change this to division. So I have x squared plus 3x plus 2 over x plus 1 squared. And that would be our final answer. Alright, so that's going to be the end of this video. Make sure you get a bunch of practice in. If you want to look for the checkup, I'll try and get that posted to either the Google Classroom or the Classroom page. And we'll see you in the next video.